Hello! Today's iReady video, Problem Solving with Inequalities, is brought to us by a parody on Alice in Wonderland. Let's begin.
Welcome to Inequality Land, a land full of wonder, mystery, and inequalities. Come, you must help me collect my teapots. It's tea time.
So all I have to do is see which numbers can be substituted in to make the inequality true?
Oh, we have ourselves a smart one here. Click on all the values that satisfy this inequality.
Okay, so here we go. We're going to start from left to right, and we're going to use our pen to substitute our values in for x. The first value we see is -10, so we're going to substitute that in for our x. -10 plus 5 is going to combine to give us -5. -5 is not greater than 10, and it is not equal to 10, so this cannot be a solution. Let's start again. 10. Let's say that x is equal to 10. 10 plus 5 combine to give us 15. 15 is greater than 10, so here is our first solution. Let's click and submit.
Right. If you substitute 10 and simplify, you get that 15 is greater than or equal to 10, and that is true. There is another solution to this inequality. You must find it.
Our next number is 5, so we're going to substitute 5 in for x. 5 plus 5 will combine to give us 10, and 10 is equal to 10. So here is our other solution. Let's select and submit.
Yes, if you substitute 5 and simplify, you get that 10 is greater than or equal to 10, and that is true. That's it.
Here we go. Okay, now, again, we're going to work from left to right. 20, we're going to substitute in for our x. 20 minus 5 will combine to give us 15. 15 is greater than 10, so this is a solution. We can select and submit.
Yes, if you substitute 20 and simplify, you get that 15 is greater than 10, and that is true. There is another solution to this inequality. You must find it.
Okay, let's substitute 15 in for x. 15 minus 5, these will combine to give us 10. And 10 is not greater than 10, so this cannot be an answer. Next number is -5. -5, we substitute in for x. Make sure we know this is negative. -5 minus 5 will combine to give us -10. -10 is not greater than 10, so this cannot be our solution. Let's double check to make sure this is right before we select and submit. 25 minus 5 combines to give us 20, and 20 is greater than 10. So we know we are correct.
Yes, 20 is most definitely greater than 10.
Great, let's go on. Multiplication. Okay, let's start from left to right. 5 times -2. 5 times -2 is -10. -10 is less than 10, so -2 is our first solution. Let's select and submit.
-10 is most certainly less than +10.
Most certainly.
There is another solution to this inequality. You must find it.
Let's see what we can find out. If we substitute 5 on our next teapot in for x, we get 5 times 5, which is 25. 25 is not less than 10, so this cannot be true. Our next number is 8. If we substitute 8 in for x, we're going to get 5 times 8, which is 40. 40 is also not less than 10, so this doesn't work. Let's double check before we select. 2. 5 times 2 is exactly 10, so this is our other solution.
10 is absolutely equal to 10.
Okay, here we go. we have negative 5 times x less than 10. So here we have negative 2. Negative 5 times negative 2 gives us positive 10. Positive 10 is not less than positive 10, so this cannot be true. Next number, negative 5. Negative 5 times negative 5 is positive 25. Positive 25 is not less than 10, so this cannot be an answer. Negative 5 times 3 gives us negative 15. Negative 15 is less than 10, so this is our first solution.
Negative 15 is less than positive 10. Positively. There is another solution to this inequality. You must find it.
One more, let's double check. 5 times negative 5 is going to give us negative 25, which is less than 10, so we found our other solution.
I'd say negative 25 is less than positive 10 for certain.
Okay, so the substitution thing is pretty straightforward.
I prefer curvy teapots myself.
I mean...
You're certainly not mean.
Well, hello there, Luna. What is it that you might be doing?
How do you know my name, and why is a penguin talking to me?
Well, you are very obvious. Everyone here knows your name because you're not from around here.
What is the deal with this place? How do I get out of here?
You'll have to take it up with the queen, my dear. And she can be quite ruthless. Allow me to help, of course. I see you have some inequalities with a few solutions, but you'll need more than that to get out of this place.
Huh?
Well, how many solutions are there to an inequality?
So we know that an inequality has infinitely many solutions. We remember that from when we graph.
That is exactly right. Let's take this inequality, for example. You found 2 solutions already. But let's make this really obvious. What if you substituted 100? Adding 5 to that will certainly be greater than 10. What about 1,000? Or 1 million? Or 1 billion? And any number between 100 and 1 billion.
They all work.
Well, you get the point. I will show you a way to find all possible solutions. But first, you must become familiar with the properties of inequalities. Let's explore, shall we?
Let's.
This app will help you discover what happens when you perform the same operation to both sides of an inequality. Let's begin with addition. Start by choosing any 2 single-digit numbers.
I'm going to choose 2 and 8. Okay, so it's telling me 2 is less than 8.
It will automatically show you the relationship between the 2 numbers. Less than, or greater than, that is. Now, you can choose the operation you would like to perform, and the app will do the calculations for you. You just need to pay attention to the new inequality to see what happens to the symbol when you perform the same operation to both sides. Let's start with addition. Select a number.
So let's add 1 to both sides.
Look, the original inequality had a less than symbol, and so did the new inequality. I wonder if that's always the case. Do a few more and see. Make sure you use a variety of examples.
So we see that we had 2 plus 1, and we got 3. And our inequality symbol stayed the same. And over here, 8 plus 1 equaled 9. And our inequality symbol remained the same. Still true, nothing changed. Let's reset.
Pick any 2 positive numbers.
Okay, 2 positive numbers. So let's pick 1 and 4. Now let's try a subtraction problem. Let's do negative 2 or plus negative 2. Look at what happened. We subtracted 2 from both sides. 1 plus negative 2 or 1 minus 2 gave us negative 1. 4 plus negative 2 or just 4 minus 2 gave us 2. Both sides are balanced. The inequality symbol remained the same. Let's go again.
Now, try two negative numbers.
Two negative numbers. Let's try -2 and -8. We know that -2 is larger than -8. Here it is on our number line. Now let's add 1 to both of these. Look at what happens. We added 1 to both sides. Our inequality remained the same. The symbol did not change.
Let's do one positive number and one negative number.
Okay, here we go. Let's try 8 and -3. Okay, we see that 8 is greater than -3. And let's try adding a -1 or subtracting 1 from both sides. 8 plus -1 is 7. -3 plus -1 is -4. We see that we added -1 to both sides, but our inequality symbol did not change.
Let me know when you think you found the effects of addition on inequalities.
Let's move on.
Let's see what you found out. When you add the same number to both sides of an inequality, does the inequality remain true?
We know that no matter what we add to both sides, whether it's a positive number or we add a negative number, the inequality symbol remains the same. Stays true. So yes, adding the same number to both sides of an inequality shifts both numbers the same amount, and the inequality remains true. That's definitely what we want.
Exactly.
Okay, next question.
You see, it doesn't matter if we start with two negative numbers, two positive numbers, or one of each. When we add the same number to both, we shift them over the same amount.
And if you add a negative number to both sides of the inequality,
Also works the
Shifts the
same.
other way.
For example, if you add -2, you're just shifting both values to the left 2 instead of to the right,
and this will also work for fractions?
as long as it's addition. It's just a shift no matter what direction. And if you add the same number to both sides, they will shift in equal amount, thus preserving the relationship of greater than or less than.
I see. The blue point is to the left of the red point, or less than, and after they both shift, it is still to the left.
That's one operation down. 3 to go.
Okay, here we go.
What do you think? Is subtraction going to be different? When you subtract the same number from both sides of an inequality, does the inequality remain true?
Yes. Now let's look at our two yes answers. Yes, subtraction can always be written as addition if you use the additive inverse and the inequality remains true for addition. Or, yes, if you subtract the same number from both sides of an inequality, you will shift each number the same amount. Let's do the first one.
Good
and go
idea.
on.
If we use the additive inverse to rewrite the subtraction problems, we will end up with addition, and we know how that works.
Yes, we do. We love addition.
So, if we start with any two numbers, positive or negative, it won't matter. Then, we subtract 2 from each, and we just shift them both to the left 2 units.
And subtracting -2 would be like adding +2,
Right,
shifting
add the
them
opposite.
both to the right.
So, we can add or subtract the same number from both sides of an inequality, and the inequality will remain true. Awesome. On to multiplication.
Let's go.
Make sure you use a wide variety of examples, and let me know when you think you figured out the effects of multiplying both sides of an inequality by the same number, positive or negative. Explore as long as you need.
Okay, so let's take an example. Let's do 5 and 2. We know that 5 is greater than 2. Let's multiply both sides by +2. Okay, 5 times +2 gave us 10. 2 times +2 gave us 4. We multiply by a positive number, our inequality symbol remained the same. Let's look at what happens when we multiply by a negative number. Let's take the same numbers, 5 and 2, and now let's multiply by -2. 5 times -2 gave us -10. 2 times -2 gave us -4. If you look at what happened with the dots shifted positions in the opposite direction. So our inequality symbol reversed. Let's move on and define these rules.
So, what did you find out? What happens when you multiply each side of the inequality by the same number?
The inequality remains true if you multiply by a positive number, the same positive number to both sides. The symbol must be reversed if you multiply by a negative number. That's what we want.
That's right.
Here we go.
If you multiply both sides of the inequality by positive 2, the relationship remains true. You can try that with as many different examples as you want.
But look at what happens when you multiply by a negative number.
They switch.
Let's try the simplest one. -1. The numbers move to the opposite side of the number line. -5 becomes +5, and +8 becomes -8. So, the blue point is no longer to the left of the red point. Thus, the inequality symbol needs to be reversed.
Okay, let's speculate. Make a prediction about the effects of dividing both sides of an inequality by the same number.
Well, we know that division is the inverse of multiplication. And since subtraction was the inverse of addition, and those were very similar, we know that division and multiplication rules are going to be the same. So here we go. I think that division will work similarly to multiplication. If you divide by a positive number, the inequality will remain true. But the symbol must be reversed if you divide by a negative number. Perfect. Submit.
That makes sense. Division is the inverse operation of multiplication.
Great vocab word.
So basically, when applying the 4 main operations to both sides of an inequality, the only time the inequality symbol will need to be reversed is when multiplying both sides by a negative, or dividing both sides by a negative number.
You got it. But one small disclaimer. You can never divide by 0.
Right.
And if you multiply both sides of an inequality by 0, both sides will become 0 and will be equal to each other. Now that you know how the properties of an inequality work, you can use them to isolate variables by using inverse operations, just like with equations. The only difference now is that you need to be mindful of the inequality symbol. Remember, you only reverse the symbol when you multiply or divide both sides of the inequality by a negative number. So, what was that first inequality you got from that mad baker? Hatter? Let's see if we can find all of the solutions.
Here it is. We have the solutions, 5 and 10. To find all of them, we need to isolate the variable x.
How can we isolate the variable x?
Okay, if we're going to solve this like a regular equation, we would draw our equation line where the inequality symbol is, right here. So there's our scale line. Now we want to get the x alone. The first thing we would have to do is the inverse order of operations. So we're going to subtract 5 from both sides.
Will the inequality symbol change its direction when you subtract 5 from both sides?
Remember, when we subtract from both sides of an inequality, the symbol does not change. So no, when you subtract the same number from both sides, the inequality symbol remains the same. Perfect.
Now we can find all of the solutions. Isolate the variable x to solve the inequality.
Okay, so if we draw our scale line and we subtract 5 from both sides, we want to solve just like a regular equation, but keep the inequality symbol. Draw our line, these cancel out, additive inverses, and we're left with x. Bring our inequality symbol straight down. 10 minus 5, which is going to equal 5. So we're going to type 5 in and move on.
Totally. The symbol did not reverse, so we know that x is greater than or equal to 5. And look, 5 is still a solution, and so is 10.
Perfect. Next question.
It's now time to graph the solution set to the inequality. Choose the correct circle for this inequality and drag it to the correct location on the number line.
Okay, we see right here we have a greater than or equal to symbol, so we know it's a closed circle, and we're going to the number 5, so right here before the 6. Let's submit.
That's a good start. If you look at the inequality where x is isolated, it tells us that x can be equal to 5. So we will place a closed circle. There. Now we need to decide which direction to shape.
Okay. Remember, we're going
Choose
to
the correct direction for this inequality.
look
and
at our
drag it to
symbol.
the correct location on the number line.
And our symbol is telling us that x is greater than or equal to 5, meaning that we want all of the numbers that are to the right of the 5. So we want it to point this way.
Yes, as you move to the right on the number line, the numbers get greater in value. And did you notice that our two solutions are just 2 of the many that are shaded on this number line? What else did the Mad Hatter give you?
Let's see.
Isolate the variable x.
Okay, here we go. So we're going to draw our scale line. Now, -5 times x. So they're attached by multiplication. We have to do the inverse, same as we would with an equation. Divide both sides by -5. Now, that key word was divide by a negative. So we know when we divide by a negative, our inequality symbol flips. So instead of having the less than symbol, we want to have the greater than symbol. Now we need to divide. 10 divided by -5 gives us -2. Make sure you put the negative symbol.
Right on. You can check your work by looking at the solutions you already have. 3 and 5 are both greater than -2. And they were solutions to the original inequality too.
Let's graph it.
Graph the solution set to the inequality.
We see up here that it's x greater than -2. So we know greater than, we just want an open circle, go over to -2 right here. And now we're going to look at our arrow. We're talking about greater than -2, so all the numbers greater than -2 are to the right, so we want our arrow pointing this way. And here we go.
I think you're almost ready to meet the queen.
Oh boy.
Let's see what else you have. Isolate the variable x.
Okay. Scale line drawn. X is what we want to isolate. In order to do that, inverse order of operations. Add 5 to both sides. So here we plus 5. Here we plus 5. Whoa. Pretend that's a straight line. These will cancel. X, this is a trick question, our inequality symbol is not going to change because we added the same number to both sides. So we're going to put the same inequality symbol that we have right in our circle. And now we're going to add 10 plus 5, which gives us 15. And we're done.
You're pretty good at this. And don't forget, you can always check your work by making sure the solutions that work for the original inequality still work for the new one as well.
Okay, let's graph.
Graph the solution set to the inequality.
Okay, remember, we have x greater than 15. So open circle on the 15. We know that all the numbers greater than 15 are to the right of 15. So we want this arrow pointing this way. And we're done.
Nice graphing.
Thank you. Next question.
Graph the solution set to the inequality.
Okay, so we draw our scale line, divide both sides by +5. +5. These reduce, and I'm going to write this down here. X, same inequality symbol because I divided both sides by a positive. So x less than or equal to 10 divided by 5 is 2. Okay. I see that I have a less than or equal to symbol, so I know that's a closed circle, and I'm going over to +2, which is right here. And I see that I want all the numbers to the left that are less than, so I'm going to put my arrow pointing this way and submit.
Looks like you learned everything you can from me. I think you're ready for the Queen's riddles. Just remember, when dealing with inequalities, the possibilities are infinite. You will find her castle right through the rose garden.
Oh boy, we're going to make
hello, Luna. Thanks for joining me.
Actually, I need to get home.
That can be arranged. You must first answer my riddles. Unless you want to be stuck here for eternity. Never fear. If needed, you will be able to ask the audience.
Oh, you've got to be kidding me.
Each of my rose bushes costs 24 gold coins plus a delivery fee of 16 gold coins. If I have at most 1,000 gold coins to spend, how many rose bushes can I buy?
Okay, let's break this down. What are we trying to find out?
Well, let's look at the question. It says, how many rose bushes can I buy? So we're trying to find out the number of rose bushes.
You're off to a good start.
You need to tell the queen the number of rose bushes she can buy. Since that is unknown, you should use a variable, like R for rose bushes.
Write an inequality that represents this situation. Just drag and drop the numbers from the problem and select the correct inequality. Then click Done.
Okay, let's go through the problem again. Each of my rose bushes costs 24 gold coins. So right here, we know that each rose bush is 24 coins. So the number of rose bushes times 24 gold coins will give us the total for how much the rose bushes will cost, plus a delivery fee of 16 gold coins. If I have at most 1,000 gold coins to spend, so 1,000 was our total, how many rose bushes can I buy? Now we need to figure out the inequality symbol. We know that 1,000 is the largest number we can have. So we need our total to be equal to 1,000 or less than 1,000, which means we need less than or equal to.
Clever. The total cost of the rose bushes plus the delivery fee needs to be less than or equal to the money I have available to spend.
Let's go solve.
I'm still waiting for my solution. Use the properties of inequalities to isolate the variable R.
I thought I solved the riddle.
No, you just set up the inequality to the riddle. Now, find the solution set.
Okay, let's do our work over here. 24R plus 16 less than or equal to 1,000. Okay, the first thing we're going to do is draw our scale line right down the inequality symbol. So here we go, scale line. Next, we know that our variable is R. This is what we're trying to isolate. The first thing we're going to do is subtract our 16 from both sides. I'm going to write that. That's a 16 minus 16. These will cancel. Everything else is going to come down exactly how we see it on this side. So we're going to bring down our 24R. Bring down the same inequality symbol because all we did was subtract the same number from both sides. So less than or equal to. And now we need to subtract 1,000 minus 16, which will give us 984. You could use your calculator to double check that. Make sure that we're correct. R is still not alone. We want to divide both sides by 24. And when we do that, 984 divided by 24 will tell us R is less than or equal to 41. So we're going to keep our same inequality symbol, less than or equal to, and we're going to type in our answer of 41. Now,
Great job. When you subtracted 16 from both sides of the inequality, the symbol did not have to change. Then you divided by a positive 24. So the symbol did not have to change there either.
Good. Let's graph it.
Graph the solution set to the inequality.
Okay, our solution set Well, is going to be based on our inequality up here. We see that we have a less than or equal to symbol, so we know it's a closed circle on 41. We also know that we are talking about less than or equal to 41, so we want all the numbers to the left of 41, which are going to be going this way. So our arrow should be pointing to the left. And
Boy,
let's go on.
you were looking for all the numbers less than or equal to 41.
Next question.
I see you have a solution set to the inequality, but be mindful, although these are all solutions to the inequality, these are not all solutions to my problem.
Please, explain more.
Well, -5 is a solution to this inequality, but I can't really buy negative rose bushes, my dear.
You cannot.
Okay, just like you wouldn't be able to buy a part of a rose bush, like 3.5, even though that is a solution to this inequality. So you can buy anywhere from 0 to 41 rose bushes, all whole numbers.
You are a very bright young lady. Just answer my final riddle and you'll be on your way.
Okay.
Right now, there are 600 everlasting roses in my garden. I want at least 200 roses in the garden at all times. If the gardener is cutting 25 roses a week to decorate my throne room, how many more weeks will I be able to have at least 200 roses in my garden?
What are we trying to find out?
Let's look at the question. How many more weeks will I be able to have at least 200 roses in my garden? Right there in the question, how many more weeks? So we're looking for the number of weeks.
Right. I need to find the number of weeks the gardener can continue cutting flowers. So I can use the variable W to represent the number of weeks. There might be more than one solution. Let's see. Write an inequality that represents this situation. Just drag and drop the numbers from the problem and select the correct inequality. Then click Done.
Okay, well, we know that we want at least 200 roses in the garden at all times. So 200 is going to be our total number over here. We also know that we're starting with 600 roses. So that's going to be the starting number that we're going to start deducting from. And right here, it says 25 roses a week or 25 roses per week, which is going to be the number that goes with our variable. Now we have to talk about our inequality symbol, at least 200. That means we want to have 200 or more. So our inequality symbol is going to be greater than or equal to, because 200 is the least amount that we want.
Great job! You can determine how many roses were cut by multiplying the number cut each week, 25, by the number of weeks the gardener has been cutting them, W. Then subtract that from the 600 roses the queen started with. That will tell you how many roses are still remaining in the garden. The queen wants that amount to be at least 200, so it had to be more than 200 or equal to it.
Oh, we have to click next first. Please hold. I'm going to rewrite it again.
Use the properties of inequalities to isolate the variable W.
Okay, here we go. So we have 600 minus 25W greater than or equal to 200. We're going to draw that scale line, and we're going to start isolating that variable. Now we see that the negative 25 is attached to the W. W is what we want to isolate and get alone. So we can't move this negative 25 yet. What we first have to move is this 600. This is a positive 600. So to move it to the other side of our inequality, we have to subtract 600 from both sides. So let's do that. Minus 600, and over here, minus 600. These will cancel. We will bring negative 25W straight down because we didn't touch any of that yet. Bring our inequality symbol down exactly how we see it. And now we have to do 200 minus 600, which gives us negative 400. W is still not alone. We have to divide both sides of our inequality by negative 25. And right when we did that, we heard that magic word negative. We divided by a negative. And when we did that, we had to flip or reverse our inequality symbol. So we should have W, flip our inequality symbol. It is greater than or equal to, so we're going to make it less than or equal to. Negative 400 divided by negative 25 will give us a positive 16. So we're going to write that down. And now we're going to write it in here. So we know we need a less than or equal to symbol and the number 16. Let's check our work.
That's right. The roses can be cut for less than or equal to 16 weeks.
Okay, let's graph.
Graph the solution set to the inequality.
So just a reminder, we have W less than or equal to 16. Less than or equal to tells us to grab that closed circle and go to the 16. The less than or equal to also tells us we want all of the numbers less than 16, which means we want to point to our left this way.
Great job! All of the shaded values on the number line are less than or equal to 16.
All right, I have your solutions. The gardener can continue to cut roses for 16 weeks or less. So, by looking at the solutions, the only ones that make sense are from 0 up to 16.
Very impressive.
Because we can't have negative weeks. So we only want the positive weeks that are less than 16 or equal to 16.
Can I go home now?
Well, what have you learned, my dear?
Well, finding solutions to an inequality is similar to finding the solutions to an equation. I just have to remember that if I multiply or divide both sides of the inequality by a negative sign, I have to change the direction of the inequality symbol.
You are too good at this. I believe I will just have to keep you here to solve inequalities for the rest of your life.
No!
And she wakes up. All right, let's head over to the quiz.
Keeks tries to run at least 45 rotations on her hamster wheel each week. She has already run 6 rotations. Which inequality shows how many more rotations she would have to run to meet her weekly goal?
Okay, well, we see that she's already run 6 rotations, so we want to have plus 6. So we're down to these two. And now we need to look at our inequality symbol. It says she tries to run at least 45 rotations. So that means she wants to run 45 or more. So that means we want right here, greater than or equal to 45. Next question.
The Mad Hatter buys his tea in bulk from the local store. A case of tea bags costs 15 gold coins. Which inequality shows the number of cases, C, of tea bags the Mad Hatter can buy if he has, at most, 200 gold coins?
Well, first we know we're multiplying 15 times C. So we're looking at this option or this option. Now, at most means that that's the largest number he has of gold coins. So that means we want less than or equal to 200 right here.
Olive buys indie music online. Each song costs $2 plus a $5 fee for using the artist's site. She has no more than $40 to spend. Which inequality shows the number of songs, S, Olive can purchase?
So we know we have 2S plus $5. So we know we're looking at this option or this option. And now it says no more than, so she cannot go over 40. So we need 40 or less. So right here, less than or equal to.
Which graph shows the solution to the following inequality?
Okay, now we're going to do some work. So I'm going to write on here and then we'll delete it. Draw our scale line straight down. We want to isolate the d, so we're going to start right here with adding 6 to both sides. 18 plus 6 should give us 4d. Bring down the same inequality symbol, so less than 24. D is still not alone. We have to isolate the d by dividing both sides by positive 4. We divided both sides by a positive 4. So our answer is going to be d, same inequality symbol, less than 6. So what that means to us is that we want an open circle, so here or here on our 6, and we're looking at our arrow. We're talking about the numbers less than 6, so it's going to be right here, the numbers to the left of the 6.
Which graph shows the solution to the following inequality?
Okay, same thing. Draw our line. We want to isolate our r's. We're going to start by subtracting 3 from both sides. Over here, the two 3's will cancel, and we're going to bring down negative 2r, same inequality symbol, greater than or equal to 19 minus 3, which should give us 16. R is still not alone. We're going to isolate it by dividing both sides by negative 2. And there we heard it, that magic word, or words, divide by a negative. When we do that, we need to make sure we flip our inequality symbol. So if it's greater than or equal to, we want to flip it to less than or equal to. 16 divided by negative 2 gives us negative 8. We see that we have a less than or equal to symbol, which means it's a closed circle on our negative 8. Okay, and now we want to look at the direction of our arrow. We're talking about the numbers that are less than negative 8, so they're the numbers to the left of the negative 8 on the number line.
Which graph shows the solution to the following inequality?
Okay, draw our line. Here we see the c is what we want to isolate. We're going to start by subtracting 2 from both sides. When we do that, we see that these 2's will cancel, and we'll bring down negative 5c, same inequality symbol, less than or equal to 27 minus 2 is 25. C is still not alone. We're going to isolate that c by dividing by negative 5 to both sides. Once again, we heard those magical words, divide by a negative, so we know we have to flip our inequality symbol. We have c alone. It was less than or equal to. We're going to flip it to greater than or equal to. Positive 25 divided by negative 5 is going to give us negative 5. The greater than or equal to symbol tells us we have a closed circle on negative 5, so here or here. And when we look at our symbol, we're talking about all the numbers that are greater than the negative 5, so we want the numbers to the right. So we're going to select that and go on.
Which value of x is in the solution set of the following inequality?
Okay, we're going to solve this one the same way we would the other one, and then think about what our answer tells us. We're going to subtract 5 from both sides. That's how we're going to start. We're going to cancel out those 5's on the left-hand side. We're going to bring down negative 3x. Bring down our same inequality symbol, so it is a greater than symbol. And 17 minus 5 gives us 12. Okay, that's an x. We're going to divide both sides by negative 3 to isolate that x, which, yes, you heard it. We have to flip our inequality symbol. So we're going to get x. It was greater than, so we're going to flip it over to less than. 12 divided by negative 3, that is a 3. I apologize for my chicken scratch. 12 divided by negative 3 will give us negative 4. So now let's look at what that means to us. We want a number that is less than -4. The pen did that. I did not do that. So the only number that's less than -4 is right here, -5. Okay, let's do another one.
Which value of x is in the solution set of the following inequality?
Okay, draw our line. We want to get that x alone, so we're going to start by subtracting 8 from both sides. The 8s will cancel on the left. Bring down the whole negative x, because we have to work with that. Bring down the inequality symbol we have, greater than 6 minus 8, -2. Now we know that every single variable that doesn't have a number in front of it has an invisible 1 in front of it. So this is an invisible 1, making this a -1 in front of that x. We need to divide both sides of our equation by -1 in order to get x alone. So these will go away, and we're going to divide over here by a -1. Now, magical words, divide by a negative. X, it was greater than, so we're going to flip it again to less than. -2 divided by -1, +2. So we want a number that is less than 2. The only number here less than 2 is 1. And we're done. Very nice job. All right, good luck getting all your answers in. Bye.